We're going to learn how to name ionic compounds. So let's jump right into that. Oh, sorry about that. Went a little click crazy. So we are going to be learning this unit how to name a bunch of different stuff. And today we're going to start with the simplest of them, in my opinion, and that's ionic compounds. One thing you need to know, all chemical compounds, whether we're talking about the ones we're going to learn today or in the future, they have an overall electrical charge of 0. It means they're neutral. So if you look at this picture here, we see this sodium ion has a 1 plus charge, chloride has a 1 minus, and when they join, 1 plus 1 minus equals 0. That means its overall charge is 0, it's neutral. That's we'll explain why that happens later. So one thing to know when we're talking about ionic compounds is they're going to form between metals and nonmetals. And we're going to show you in a second this stairway of division. So most of the periodic table, starting on the left side, are metals. And then once we come to this stairway, I'll show you everything to the right of them are going to be nonmetals. And that's going to be important here in a minute. So if we look at this screen, sometimes it's usually marked here like you see here. See this bold line under the B, and then it goes down, bold line, bold line, bold line, bold line. So everything on this side are the metals. And if you notice, they have plus charges here, and then all this that's left over here, those are our nonmetals. Who cares, right? Why are we pointing out this? Well, when we're talking about ionic compounds, they're always going to form between metals on the left side and nonmetals on the right side of the periodic table. So, quick review. Ions are when atoms gain or lose an electron, and the reason they're doing that is to get that full octet, that full outer energy level. So if we take a nice look here, sodium here has 1 valence electron. If it loses that electron, this level beneath it here becomes the last energy level, and it already has 8 electrons. So that's full, that's happy. And this sodium here that lost an electron is now a sodium ion because it has a positive charge. How does it have a positive charge? It lost a negative electron, so now it has 11 positive protons still, but it only has 10 negative electrons since it's lost one. Well, that leaves 1 positive over. All right. Here's some new terminology. Cations and anions. Cations are positively charged atoms. So once they lose that negative electron, they become positively charged. We call them cations. I used to have a hard time remembering the difference between cations, but then I learned a trick to remember the other kind, anions. Anions are A, because it starts with an A, negative ion. So I just think of the N stands for negative ion. So anions are a negative ion, and what happens is when something gains an electron like chlorine does, it's a negative ion, making it an ion. Some general charges, eventually you'll memorize these. We're going to write them on our periodic table so you don't always have to figure them out. But remember, elements are organized in those groups in the periodic table based on the number of valence electrons, and that's what determines your ionic charge. Here's a nice summary, and you might want to copy this onto your periodic table. Everything in this group has a +1 ionic charge. Everything in this group has a +2. These are special. They're +2 or +3, so we're going to ignore them for today. We'll spend a whole nother day talking about those. +3 and 4 for these two groups. And then we get to the negative, the anions over here, and -3, -2, -1. And remember, our noble gases have 0 valence electrons. They already have a full octet, so they're very unreactive. Oops, sorry. Go ahead, press pause while you put all that into your notes. So this would be a pair deck, but you're not in pair deck right now. So just kind of think to your head, what's the charge of all compounds and molecules? Hopefully you remember it's neutral or 0. What's it called if an atom gains or loses an electron? Hopefully you remember, those are called ions. Anions blank electrons and have a blank charge. Remember, N for negative, a negative charge. So this is negative. And how do you get negative charges? You gain negative electrons. So gain here and negative there. So we've said some of this. We're going to make sure we put it here specifically. Ionic compounds are made of positive and negative ions. The positive ones are the metals. The negative ones are the nonmetals. These elements aren't actually attached. What it brings them together is what's called electrostatic attraction. In other words, opposite charges attract. So they're held together by the opposite charges they have. Here's some examples we'll learn how to name eventually. NaCl, sodium chloride, metal, nonmetal. Calcium bromide, metal, nonmetal. Potassium iodide, metal, nonmetal. Chemical formulas, like these we've seen, they're telling us the kinds of numbers of atoms in the smallest representative unit of the substance. In other words, technically, Na2Cl2 is equal to NaCl. But we never write it this way because we have to represent it the smallest way. So 2 and 2 can be divided by 2, which reduces them both to 1. So we always have to put it in that lowest form, which is why it's always written as NaCl, sodium chloride, or table salt. And I just showed you this. And what this is saying, there's no such thing as a molecule of NaCl because they're all attracted to each other, like that picture we saw in the first one. So if the charges cancel, we just write the symbols. +1, -1 equals NaCl. We said that. No, common sense. It has to be equal to 0. But look at this one down here. We'll get into this more eventually, but just to introduce it, calcium has a +2 charge because it's in group 2. Chlorine has a -1. Those don't cancel out. I can't change the charge, but I can add more of them. So if I write 2 Cl's, 2 times -1 is now -2. We said the calcium has a +2, so now they do cancel out. So 1 calcium will combine with 2 chlorines because then the charges balance out. Go ahead, pause while you put this into your notes. If you want to, go ahead and Google search this, but we don't do song breaks when you're making up to get caught up, unless you want them. All right, so it's going to be pretty easy initially, because we're going to keep adding types of naming. So right now, you're only going to have to know one way of naming, but it's important that you learn how to tell the difference, so when we add different types, you know what you're doing and don't get confused. And it's always going to be based on whether you are naming ionic or covalent compounds. And how are we going to know that? We're going to look at the first element in the compound. If we're in, where'd it go? Group 1 or 2, we have a metal, and it's going to be bound with a nonmetal. That's what we're talking about today. That's all we're going to be learning about today, how to measure these, name these ionic, cation, anion, metal, nonmetal compounds. And when you do that, it's pretty easy. You just write the first metal, the cation, and then the second word, the nonmetal, the anion, you change the ending of it to IDE. So we look here, we said cation first, metal first, so Na, if you look it up, is sodium. Br is bromine, but we change the INE, we change the ending to ide, because that's how you name ionic compounds, so it's called sodium bromide. Magnesium is in group 2. So we said anything in group 1 or 2 will be, if the first element's in group 1 or 2, this is how we're going to name it. So magnesium is magnesium. You know, change the first word. Fluorine becomes IDE, fluoride. Here's a few more. Potassium, chlorine. Potassium is in group 1. So we name it how we have been. But just name the first word. The second word then becomes chlorine, becomes chloride. Aluminum oxide. And actually, this is a little different. We'll talk about that one another day, but it's the same principle here. So go ahead and press pause while you fill out this in your notes. Oops. So if you're smart and not just trying to get done and be quick and actually trying to learn this, because you're going to need to know it for quizzes, I would press pause here and try to name at least a few of these, like write them down on a piece of paper or type them on your note guide. Try to fill that part of your note guide out and then just fix it if you're wrong, because eventually you're going to need to know these. And today there's only one kind to know, so we're just getting this basic pattern of an element that's in group 1 or 2 bonded with a nonmetal. So once you pause and find that, I'll give you the answers. There's your answers, and if you notice, the first word each time is just the name of the element. Every second word ends in "ide" instead of its normal name. The reason being, all of these elements are in group 1 or 2, and whenever that first element's in group 1 or 2, this is how we're going to name it. And you should be good.